So there are several types of solar cells, like there are solid-state solar cells, there are thin-film solar cells. But today we'll learn something about the dye-sensitized solar cell. The dye-sensitized solar cell is kind of cell which is combination of dye, as name appears, and semiconductor. And as it is solar cell, so it will produce electricity from the sun. This is freely available. You can see on that side that the whole world is using lot of fossil fuel, and every day by day this demand is increasing. So we have to search something that may be an alternative to the source for the future. So let us understand that what is the process, what are the theory which acts beyond that, how this dye-sensitized solar cell works. So it is very similar to the what you can see. It is very similar to the leaf. How this tree works, what is the process of the photoactivity of this green leaf. So you can see this green leaf. So why this color is green? This green color is due to the chlorophyll which is inside this leaf, and that color is photosensitive and photoactive. A very similar thing, very similar process occurs for this dye-sensitized solar cell. The inside this leaf, the dye is chlorophyll, but the dye-sensitized solar cell, which is specific to the electricity production, the dye will be something specific, like ruthenium pyridine type dye, or TPA based molecule dye, or dye which can be came from this leaf, or dye which came from fruit juice. So this dye-sensitized solar cell, you can even make this cell by simply using fruit juice. So you can imagine how quickly you can make this dye-sensitized solar cell. So now let us understand how this whole process takes place. What are the function? How this process takes place? So when you take any dye-sensitized solar cell, it is quite different from the regular solar cell. In dye-sensitized solar cell, we have to take two type of conducting glass, and you have to coat titanium dioxide over one of the plate, one of the conducting plate, and you have to put another conducting plate that may be catalyzed by like carbon or platinum, whatever, and there should be some electrolyte. So that is the difference which one has to keep in his mind, that dye-sensitized solar cell, there is kind of electrolyte. In solid state device, there is not such an electrolyte. There is p-n junction, and when light interacts with that p-n junction device or p-n junction type of solar cell, there is creation of exciton, and the electric field which drives electron is also act due to the material which is in the solid state device. But for this dye-sensitized solar cell, the process is little different. What is the difference? Let us understand the difference. In dye-sensitized solar cell, when the sunlight come to the, like you can imagine this as a cell. So when light interacts with this layer, so there is just imagine there is kind of titanium dioxide layer. So titanium dioxide layer, there is some dye. You have to sensitize that titanium dioxide molecule with some kind of dye, which is the main thing in the dye-sensitized solar cell. So that dye will produce electron, and electron will be transferred through the whole circuit containing titania and come back to the circuit. But due to the loss of that electron, dye will degrade. So there should be some source which will regenerate, or which will compensate this electron loss in the dye. So that's why the electrolyte what is being used in the dye is provider of that electron, or it is compensator of the electron loss in the die. So that's why this dye-sensitized solar cell, we need a kind of dye and we need a kind of redox electrolyte. So now we'll see the whole process for functioning of dye-sensitized solar cell. The research group in the University of Utah and the Department of Metallurgical Engineering is dedicated to the photovoltaic material synthesis and development. We already have synthesized copper zinc tin sulfide based material that is kind of solid state device, and now we are developing this dye-sensitized solar cell. So we'll demonstrate one experiment where we can see that even in the room temperature, even in the room light, how good voltage we are obtaining, and we are also obtaining good current, and we'll see how this cell works. We'll see a kind of demonstration. Thanks.
What you are looking at right here is a dye-sensitized solar cell at room light. This cell is producing 233.84 millivolts at only room light. The synthesized material is being held before your eyes now. As you can see, it was synthesized in this lab.